We are back for another video. So this week we'll be talking about DNA testing, gene testing, whatever you want to name it. And there are a lot of complex terms thrown around for somebody who doesn't understand anything about this. Like, hey, you need to do methylation and whatever. What the hell is DNA genetic testing? Or can you just put it in
Yeah,
broad
yeah.
sentence? What the hell is it? And what do people mean by using all these terms that, hey, you need to do this and everything's going to be fine?
Okay. So number one, right? Genetic testing, DNA genetic testing. Most of the time, like there's hundreds of genes, right? So when you get a DNA, people think that, oh, when I get a DNA test, they're going to see everything. And the truth is they're not. The reason for that is because we don't even remotely know what all of them do. So really there's a handful, right? That, depending on exactly what you're looking for, there's anywhere from just a few, like under 10, that most genetic testing websites and people that advise for that are going to be checking. We'll go over those. You will have heard some of those, like the MTFR gene, which is for methylation, the DOA gene, and there's certain other ones. We'll go through those, but those are kind of the main ones that you're going to hear about. Those are the main ones that people are that are promoting this type of thing are going to be talking about. But the truth is that there are thousands of genes. We just don't know what they do. And they really haven't been given names other than letters and numbers. And that's kind of where we're at in the process of genetic testing. Okay. Now, these certain 10 or so that are more well known, we do know the pathways, and I'm going to show some of those in there, not for the purpose of trying to tell you how they work intertwined, but to the purpose to show you that the cofactors involved in this gene working fast or slow or not at all or not very well has an immense amount of environmental impacts, just like your blood work. In fact, there will be some blood work markers that will come up in some of these genes because they end up in some kind of byproduct, some kind of waste out of that gene pool that ends up in your blood, right? So some of the markers that we test for in blood are actually directly related to somehow of how this genes or certain of one of these genes are working. And
Let
the
me
point being,
interrupt you a little
go
bit
ahead.
because, like, I need to kind of highlight that more. A lot of people don't understand that genetics does not mean you are set and done just for that. It's a switch on and switch off. It's just, hey, these are the things that are available to you. And more often than not, people misunderstand that this is it. Like, I have these genes, that means I'm gonna get this cancer and I'm done.
Correct. Yeah.
So
Something to even bring more clarity to that conversation is we now know that genes, DNA genes, right? So this is in the nucleus of the cell. That's where these genes reside. They're not only just turned on and off, some of them work that way, but they're also dialed like a volume dial. So some of these genes are working really fast or really slow. They're not necessarily on and off, right?
and this is the methylation that we often hear people
Yeah,
talk.
methylation is one that works like this. There's several of them that kind of work like this. And the point being is that the reason why it's a dial type mechanism is to react to environmental and nutritional inputs, right? So these will regulate depending on the time of year and depending on the environmental exposure that you're getting, and so forth, right? So that then brings more complexity to this, right? Like it's one of those things where just like we preach with blood work, which is, hey, this is a snapshot of what's going on right at this moment. This is not going to stay permanent if you keep eating the same way because the season's going to change. So even if you keep the diet identical, the result in your blood work will be different at a different environmental stage in your life, whether
And
that's a year
that's
from.
also why we highlighted, if you see red in your blood test, don't get panicked. It just
Right.
it's just showing what you're doing now. Like, I just reviewed blood test yesterday night, and I'm like, and the guy was already on a start to buying all the supplements. I'm like, whoa, stop! I need to speak to you first.
Yeah.
And then we had a talk, and I'm like, no, you don't need any supplements. You just need to
Right.
check your bits that you're doing incorrectly, and we'll check in 6-8 weeks, see if
Mm-hmm.
that works. If that doesn't
Yeah.
work, then okay, then we're gonna go for something something harder.
100%. I 100% agree with that in that terms, because that's exactly how it works, right? Hey, you make a small change and hey, look, some of these blood markers completely correct themselves. There's no need to take anything else. And if you took something else, you're going to impact other parts of the blood work. These genes, all genes, work the same way, right? And something important to understand about genes, right? You may be born with a COMT gene or MTMFR mutation, right? Because that's the other word that gets thrown out. There's a mutation in this gene for you, right? All mutations don't mean that the gene is not working. It, like I said, it could be working very slowly, or it could be working really fast, right? And so then you have to take into account that, okay, why are these genes? What's telling the genes to do that? And that's your mitochondrial DNA. This is a big deal. A lot of people don't make this connection. Your mitochondrial DNA, it has its own DNA. That's not your DNA. It's its own mitochondrial DNA. And that is running in the background, signaling to the nucleus what genes to speed up or turn on. So the way I like to think about it is all the genetic testing that they're talking about is the filing cabinet in the nucleus of all the different things that your body can do. And then the mitochondria then signals to the filing cabinet, hey, pull out this gene and turn it up a little bit, or turn it down a little bit, or completely turn it off or turn it on, right? So it's the one telling and dictating the filing cabinet, the storage mechanism in the nucleus, which genes to upregulate, which genes to downregulate, which ones to turn on and off. That's where the storage of all those memories are and how to execute on them. And the mitochondria is then paying attention to your environment and then telling the nucleus what to do. That's how the system works, right? So
let
when
me
you
just
understand,
follow up on that. So I'm just imagining I'm somebody who's listening to you talking. It's basically it sounds like you're saying your mitochondria needs to be looked after and needs to be kept healthy for you to not get your DNA damaged and so on and so forth.
very, very much so. That's how, like, once you understand that, how does the information flow to make your body work? Now things start to become a little bit more clear about, okay, anything that's good for my mitochondria is also going to be good for my genes, and anything that's bad for my mitochondria will essentially come out to be accelerating gene mutation, which is also called methylation, right? So this goes back to this methylation concept in a big way. We know this from astronauts. In fact, there was an experiment where two identical twins, right? So one went into space, one stayed on the planet. The one that came back had all of his methylation genes accelerated, right? Why would that be? He's exposed to way more radiation. He's obviously suffering the detriments of being in space. Why would that happen? The reason is because environment dictates genetic mutation, right? Because that's how evolution works, right? So if you just take that rudimentary concept that I just said, increasing methylation means that the genes in your body understand that there's something happening in the environment that it needs to adapt to at a faster rate than normal. So it upregulates methylation so that genes change faster. That could be good in long-term evolutionary perspective, right? Because, hey, if I introduce you into an environment that you've never been exposed to, you need to adapt as fast as possible. That's what's going to make you survive. It might not make you as the individual survive, but then you will pass on that information to the next generation that will survive in that environment. That's how methylation is linked to gene mutation. So when you get an MTFR gene test that shows that your methylation is poor, it might not be a good idea to increase methylation. It could be your body adapting to, hey, maybe there's a problem out there and we don't want gene mutation to happen at an accelerated rate. Let's turn that down. And then you pass that on to your children. It's mostly mother to mother. So that so it quiets down the mutation of genes. It may be a protective mechanism, is what I'm getting at. So just in knowing the concept of flow of information, you can quickly come to the realization of, oh, that could not be something you want to mess with in terms of supplements, right? Like, hey, I'm going to take all of these B vitamins. I'm going to take all these methylated B vitamins so my body doesn't have to methylate it anymore. Well, all of a sudden, methylation goes through the roof. You may end up experiencing short-term benefits. Hey, I have more energy. I can process things a little bit faster. But a couple of years from now, genes might be shifted, other genes, right? And that's why I'm going to go through the effort of showing you, hey, the MTFR gene is not by itself. That's the other concept people don't understand, is that, hey, my certain gene, one or two genes might be underperforming. So let's upregulate them with whatever we come up with, whether it's a supplement or a drug. Well, that's going to influence other genes that might not have anything wrong with them, right? So that is, that's why I wanted to take the time to highlight this before I start sharing my screen, so that we have something to really kind of look at. So
would it be too far-fetched to think that it affects your even like response to training, response to nutrition, and so on and so forth? Let's say I've moved from Latvia to UK, and now I've lived here for many, many years. I'm more adapted to this environment. And then I go, let's say, to California. Now my body is taking a long time to get used to that.
Correct. Yes.
And I can just link to that I travel a lot, and every single time I go to different country, and if I stay there longer than a couple of weeks, my body just feels weird.
Yeah, because it's adapting. It's literally adapting to that particular environment in every sense of the word. The type of sunlight you're getting, the type of moisture you're getting, all of that type of stuff. It's being calculated by the mitochondria, and the mitochondria is slowly changing some of these genes that we're going to be talking about. So right now, just as a high level to kind of wrap up what I said before, the nucleus is where your genetic genes are, your nuclear genes, and the mitochondria are all these organelles on the outside. They have their own DNA inside of them, and that gets passed on unaffected or unaltered from mother to mother, or mother to offspring. So your mother gave it to you, whether you're male or female, and only the females will pass on the mitochondrial DNA. We talked about this before, but that's how it works. You have genetic testing, which is looking at the nuclear genes, and then you have mitochondrial genes that are different, right? So those are not going to be tested for. To my knowledge, there isn't individual genetic testing for mitochondrial DNA yet, because that would be a lot more influential, because that would tell us exactly how your mitochondria is interpreting the current environment. But we don't have those types of tests yet, or at least not to my knowledge, not publicly available. Now, if we, let's see here, scroll down a little bit, and we'll get to some of these other ones right here that I wanted to bring up because we're going to see some of these in terms of, so at the end product, right, genes and methylation and stuff like that are going to influence things like energy, things of like well-being, mental processes. And at the end of the day, the way that they're influencing them is by the regulation of dopamine, adrenaline, noradrenaline, dopa, your thyroid hormones, melatonin, etc. All of these coming from these amino acids. So we can see this actually in gene testing. So now I'm going to kind of show you what that looks like right here. So let's look at this particular pathway. This is a gene, right? This is a bioprine gene. Now, if you look at it right here.
Your screen is stuck, nothing moved.
Oh, okay. Let me see if I can stop sharing my screen and share the whole thing.
So looking at that, it's basically looks like correct me if I'm wrong. Yeah, I can see that. So we would still reassess if I was you and somebody approached me, hey, I want to do DNA testing, blah, blah, blah. You would still probably go, hey, let's assess your habits first. Let's check your blood test first. And then if something is off and you have the means to do this, let's do this.
Yeah, because then it could give you a little bit more fine tuning of the exact thing, right? Because now, for example, maybe you come up with this bioprine gene pathway because maybe you're lacking dopamine, right? We assess that something is going on with that first slide where I said, this phenylalanine and tryptophan, which is right here, right? So if you see right here, tryptophan is a main thing that's going to go into serotonin and melatonin secretion through that pathway. Tyrosine is another amino acid that, again, is influenced by UV light that then eventually turns into L-dopa, and then we could go look at that. And then if you see, there's lots of little interactions here, right? So Tryptophan is influenced by vitamin D and darkness. So your vitamin D status is going to influence that. It can upregulate it or downregulate it by that. If we look over here, vitamin C and vitamin D influence the amount of tyrosine that's going to be turned into L-DOPA, right? And reactive oxygen species, right? We've talked about this in other videos where these are baseline things that are coming from the mitochondria. So the mitochondria is, in essence, has control of how fast or slow these move through these pathways, not when you look at this and you say, for example, because some of these pathways will be highlighted in some gene testing of, oh, this is operating slowly or particularly fast, like I mentioned earlier. And so if you see some of these sections that are operating fast, well, then you can see with more detail what are the things that are influencing it to operate fast or influencing it to operate slow, right? Again, the purpose of this is not to get in real precise detail of everything in here. It's to show you the level of interaction that the mitochondria has on your genes, right? Reactive oxygen species right here, again, is going to influence how this cycle influences this way, right? So that's just one of those genes. Let me go ahead and show a different gene right here. One that we were going to talk about, the methylation gene. So
yeah, and again, looking at that, it's like if you do it on your own, you're pretty much going to get very similar outcome on understanding what you need to do by just doing blood tests as well. I do know a lot of people who have done a really good job at detecting cancer early and all those kind of things. Can that be done with this type of test?
Yeah, now that's a little bit different because those aren't really going to be looking at genes. They're similar though, because they can see, hey, certain genes get upregulated. It's the same thing as blood work, right? Certain markers are going to be through the roof when you have a cancerous state. Certain genes will be doing the same thing.
So if you
Yes,
change them, you can predict, maybe in future you'll have issue with this type of cancer.
unless you change it, right? Exactly. So that's another concept that's very good to highlight at this current moment. Okay, say you get a blood marker, for example, right here. We're looking right at it. Okay, so right here, this is the methylation pathway, right? If you look right over here, uric acid is the final dump of adenosine in this homocysteine pathway that comes all the way around. So in other words, you can look at your uric acid level and start seeing, oh, we are really dismantling adenosine in this cycle at a very fast rate, and we have an abundant amount of uric acid. Well, what can that tell us, right? If we come look upstream, we have the SAM gene over here, which donates methyl groups. It could be literally that you're methylating too quickly, right? So uric acid being elevated means that methylation is very high in you. That means that you have the potential for lots of gene mutations at a faster pace than somebody that has much less methylation going on. And you could see that in a volume type manner on your uric acid level. And I've seen this, right? People that are around a lot of electromagnetic fields, uric acid is quite high. Why? Because they're either reacting in a way of, oh, their mitochondria I'm speaking about is reacting in a way that's going, hey, this environment is definitely something we're not used to. We need to adapt to it at a faster pace. So they raise uric acid. That's slightly protective because it's methylating faster, but it also means that genes are moving and changing at a faster pace. Whereas other people in the same situation might experience the exact opposite. Their uric acid gets dropped rock bottom, like out of the bottom of the range in their blood work. And now you can clearly see that their methylation is running slow. But that might be a protective mechanism. That's why you need to speak to them. Hey, where do you live? What's going on with your day-to-day habits? Maybe you work at a power plant, right? And that would explain some of the accelerated methylation or the decelerated methylation. But again, there's a marker right there in the blood work, if you know what you're looking for, that can tell you in a volume type manner, hey, we should probably look into this MTFR gene or the methylation gene process for you specifically, because you can quickly see over here, right, all the ins and the outs, right? There is lead and mercury and things of that nature that it will influence some of this, right? Depending on what you find from that person. Fasting will influence some of this, right? That's highlighted right there. But more importantly, you can start to see that reactive oxygen species also influences this. Selenium and other flavonoids influence this. We've talked about this in terms of, hey, one of the most basic dietary things that a lot of people miss is just generally getting a lot of iodine and selenium in the form of fatty fish or cold water seafood that also happens to bring lots of zinc, lots of magnesium, and lots of DHA. So we
And this is
see,
something I actually see in people who are like refusing to eat fatty fish. Like the uric acid is off charts.
yeah, because something is influencing the dumping, the stopping of this cycle, right? Like the cycle is supposed to be able to be recycled. Like that's the whole point of it working in this manner. And when things fall apart, boom, it gets dumped right down into here, ends up in uric acid, right? So we can see that without looking at your genes. We can see that in your blood work if you know what you're
Just
looking
to
at.
expand a little bit more, can you just maybe spend a little time and talk about what can happen if your uric acid is high or low?
Yeah, so generally, if uric acid is high, you're going to experience more inflammation, right? Most people are going to be familiar to some degree with something called gout, which is inflammation of the joints, which is also associated with uric acid being high. They are not one to one, meaning if your uric acid is high, you don't have gout, but you can have gout, and if you have gout, your uric acid is most likely to be high. Uric acid by itself is just increasing um, inflammatory responses, and at the same time also uh, increasing reactive oxygen species or showing a sign of reactive oxygen species being elevated, right? Um, Other things that can inhibit, uric acid being low, for example, having a lot of people don't know this, but a lot of ginger, a lot of curcumin, a lot of anti-inflammatories, if you will reduce uric acid, because uric acid is it's not a direct one-to-one inflammation, but it's a good sign to be like, hey, you're kind of inflamed, your uric acid is kind of high, things are clearly moving at a fast clip in this methylation scheme, and uric acid can start to tell you a little bit about it. For most people, uric acid is going to be in the zone that's very acceptable. But when you have, again, going back to where are you right now and where are you going, right? If you get blood work and your uric acid is still in the right zone, but it's moving up, right, consistently year after year, that starts to tell you something is going on in here, and you can look at this a little bit more in depth. But it's all going to have influences on what's your environment doing to you, right?
And it's
At the end
probably
of the day,
good to add to the concept that you don't need to kill all inflammation because you need inflammation for you actually to get better.
correct. Yeah, yeah. Low uric acid is also a problem. Low uric acid tells us that you're actually probably not protecting your nervous system very well, right? Like if it's rock bottom. So again, that could be influenced. Like some people are going to try, some of their genetic makeup is going to try to survive. Methylation will go much higher, like we saw in the astronaut, right? Again, think about it. This is an astronaut, elite of the elite, somebody who is incredibly fit, both mentally and physically, that's going up to the space station. It's not a wonder that his methylation went up instead of getting crushed. His methylation went up, uric acid went up, so that he could adapt to the environment. Some people are not going to be that genetically blessed, and their uric acid might drop out of the bottom because their body is not choosing to protect them from that environment. It's just being dismantled at that point. So uric acid is something to pay attention, both high and low, and everything in between as a marker that you follow, that you track.
So
When it comes to
something
methylation,
you just kind of mentioned, can checking for methylation pathway predict effects on psychological well-being?
yeah, most likely, because the methylation pathway is also going to involve a lot of the B vitamins. Everybody's familiar with folic acid. You know, if you have the MTFR gene that's mutated, then they recommend to take methylated B vitamins and stuff like that. And most people will experience some level of energy bump in that, but again, you want to make sure the environment that you're in, because that may or may not be the right call. And so, yeah, that's going to have a mental effect. Methylation in general is going to have a very pronounced effect on mental activity, right? Choline is another one that gets upregulated or downregulated in this cycle, and that turns into cholinergic activity. So just your brain function can be influenced by that. And I'm not saying that methylation isn't important. I'm saying methylation is dictated by a lot more than just taking methylated vitamins, right? Because that's the recommendation from just about everybody that recommends genetic testing. They're like, oh, we're going to test your MTFR gene. If your MTFR gene comes back mutated, here's some methylated B vitamins. By the way, they're also my brand that I have a proprietary blend on and whatever. They're making money off of you because they know that the test is going to come back with that MTFR gene slightly underperforming. Why? Because this is common in the modern world, because methylation is the first thing that your body starts to change whenever you're in an electromagnetic field environment that's foreign to the planet. They know it's going to be off. They can make a lot of money that way.
Yeah, so this could explain why when I was traveling every 2 weeks to States and back, transatlantic flights, 10, 12-hour flights all the time, that I had to rely on choline supplements a bit more than I need to do now. I was literally having brain fog unless I had choline supplement after my flights, whereas
Mhm.
now for last, nearly a year, I don't need that. Well, probably we know already my blood test was all over the place. And for
Mhm.
somebody who's not as healthy as myself, that could probably be a really big red flag.
Mhm.
Uh, so there might be, this is my guess, let me know if you think it's right, but my body is adapted more to that kind of stress now, way more.
More than likely to some degree, right? Like there was some level, just like any level of training, right? If you've never done a particular movement before and you do it often for 6, 7 months, when you come back to it, it's not nearly as foreign. There is some level of adaptation going on there to environmental stressors for sure. There's even the other concept where you can kind of clean up all your environmental stressors to the point where you become more sensitive whenever you encounter that environmental stressor before. So it alerts you to it. There's a couple different ways that the adaptation can happen.
So DNA, all these kind of things, what can affect it from habitual standpoint, let's say, and maybe nutritional as well? You know, is there an alcohol involved? Is there, you already mentioned,
Yes. Yeah.
okay,
Yeah. So,
daylight,
so,
nightlight, and all those kind of things.
mhm.
Let's talk towards nutritional style. Everything that we put in our body, what can affect it in maybe positive and negative way? What do we know at the moment?
Yes. So, in terms of all of these, right? So broad level, your thyroid, your blood work, all of that, and then very granular level, these pathways that I just showed. If you just take a moment and kind of look at these, there is a lot of involvement with zinc, magnesium, selenium, iodine, and copper and potassium. These are all things that should be coming into the body in the way of from the food, right? So things that will influence the most, like foods, are going to be making sure that your micronutrients are on point. The easiest way to get the pre-packaged micronutrients, because it also needs the cofactors of those micronutrients being uptaken correctly, especially minerals like zinc and copper and iron and magnesium. Those are heavily influenced by other cofactors. Things like seafood jump right to the top of the list because they're already pre-packaged correctly and they already have an abundance of all of those, right? Not only to work these gene processes, but also directly used in brain function, right? At the neurological synapse level, the actual structures, right? So, and other things that will impact this in a big way: smoking, caffeine, like regular caffeine consumption. Like the caffeine comes up a lot in a lot of these functioning genes because caffeine affects adenosine. And adenosine is a baseline molecule that the body is paying attention to because adenosine comes from the dismantling of ATP, right? ATP is the currency of the cell. So when you drink coffee or caffeine in any format, really, you're affecting adenosine. When you affect adenosine, you're affecting genes, right? That's as simple as you can put it. So coffee and smoking are big non-nutritional factors that people don't ever really think about. Besides the smoking these days, but coffee is one of the, caffeine in coffee is something that's kind of in the background of everybody kind of consumes it to some degree, but they don't really think twice about what it does. Right? I'm not saying that it's good or bad. I'm saying it has an influence. Right? Then all the copper and the minerals that's going to come from veggies and seafood. So seafood first, then your veggies, and then comes the hierarchy of kind of what we spoke about before in terms of grass-fed animals or animals that spend time outside. Because the animals that spend time outside are going to have these same genes and they're going to be functioning correctly. That means that their tissues are going to be depositing the right amount of copper in them, the right amount of zinc, the right amount of magnesium and manganese inside of them. So that then
I'm
becomes
guessing you're
higher.
not gonna touch into organic grown food because there is just so much gray areas that
Yeah, I don't spend a lot of time with that. Especially with plants, because see, you can be organic and still be synthetic, right? Because if that plant was grown inside, which is common, right? That's very common for plants. They grow them exclusively inside of grow plants, inside of grow rooms, but they didn't use any chemicals. Is that organic or not? Well, if you understand how light impacts mitochondria and chlorophyll, which is in plants, it's all about light. If the light is off, that plant is now synthetic, right? So I don't dwell too much on the organic versus non-organic plants. I do dwell on the animals you're going to eat because they're going to influence a lot more of these pathways because they're going to bring a lot more bioavailable minerals and ions, right? That's why seafood is one of the main ones because you can easily get seafood that's been unadulterated. Like, for example, in the US, canned seafood is not allowed to be farmed. It has to be wild caught. So immediately you sidestep that whole industry if you go with a canned variety of seafood. For the most part, it's kind of like that in the rest of the world as well. That most canned seafood is actually wild caught because it's not really damaged goods. It's just not pretty, right? It's not a pretty fillet anymore. So they don't send it off to be get it at the highest price, but they don't want to waste it. So what do? They just can it immediately on site. So that preserves all the nutrients and it preserves all of the actual things that you want from a wild caught state right at the beginning. So a lot of people don't really understand that industry that well, but that's what happens. And that's actually why I recommend canned seafood on a regular basis. Treat it more like a supplement than anything else.
yeah, it's like where I come from, salmon was not such a big thing, but where it was sprats and things like that, it's very highly fatty fish
Mm-hmm.
anyway. But they were
Yeah.
like little tiny things that when you put in a dish, it doesn't look good.
No, exactly right. Like that canned seafood in general is not going to really look that great, but it's going to provide all the necessities. And then the hierarchy, right, is animal products that
In
are grown
seasonal as
outside of.
well, so we would always have a season where we would just eat that as much as you can, and then
Yeah. Yeah, and that's pretty much for most people that live in a four-season environment. That's what's going to end up happening is you're going to not necessarily have salmon all the time or canned seafood all the time. It's just going to come in seasonally in the colder months of the year, and you are going to feel better because it's going to provide these at a much higher rate than others. So nutritionally, the other thing about seafood, and then lifestyle things that will influence this, right? I brought up the dopamine pathway. It starts with L-DOPA right here, but if you can see over here at the top, we see the amino acids that we've talked about before, phenylalanine and tyrosine. They are the ones that are going to eventually, hopefully, turn into your dopamine right here, your noradrenaline, and your adrenaline. Those start at the top. What's going to start at the top? Vitamin C status, smoking, and UV light interacting with these amino acids to get them moving in the right direction. If that's not the start, right? Like if the starting point is already messed up, it doesn't really matter what's going on in these other cycles, right? Like if you kind of look down over here, copper and water and vitamin C status influence dopamine into norepinephrine at one rate or another. But that's the nuances of once it's already L-DOPA. If it never got any UV stimulation, phenylalanine and tyrosine never went to L-DOPA to begin with, right? So you have to make sure you start at the right thing, just like a map, right? If you miss the exit, you already got to backtrack way back, right? But if you start, hey, I got off on the right exit, okay, now we can start looking at more details of what else is going to influence that particular pathway, right? So we look at another gene right here, the COMT gene, which is also talked about a lot, influences lots of different places in this whole pathway. So that's a completely another gene that's doing a whole different other things that's going to influence your dopamine and noradrenaline, right? So that's the level of intricacy you're dealing with. It's not as simple as, oh, I got this gene test and these genes look off and these genes look normal. If you look at this, well, if I modify some of the things in here through a supplement or a lifestyle change, I'm also going to modify this other gene that's doing other things, right? So most of the time, I find it to be a waste of time to go right to genetic testing,
Right.
in the sense of what most people are presenting. Right. Now, you can go through genetic testing for screening, just like you do for blood work. And what you're screening for is, hey, certain things that are out of range then dictates a deeper look. That's about as good as you're going to get. It doesn't tell you what to do. Right. Like that's the key point. Is it's not going to ever really tell you what to do. It's just going to tell you, oh, we should look into a few more things. Right. So if we look over here, we have cocaine, nicotine, methamphetamines, Wellbutrin, all the psychological drugs, right? Depression drugs, ADHD drugs, all of those are influencing all of these endpoints for dopamine, right? So if you're taking any of those, there's going to be some backward feed into here. You're probably going to make more adrenaline and noradrenaline because dopamine is not flowing in that direction, right? So you have to take all of that into account when you do genetic testing. It's not as simple as the gene tells you everything. That's not even really how they work. The gene is only telling you what the mitochondria is currently telling the body to do.
So let me tell, because it's extremely complex and we probably can spend hours and hours and hours of this alone, but we'll try to make it concise and precise so people can understand it and use it. So gene testing as such is better used as a troubleshooting mechanism to understand what you might not be doing optimally at the moment. And if, as long as you get your protein intake correctly, less processed foods, good habits, eat according to seasons and regions where you live at, you are more than likely to stay healthy for longer. But genetic testing can show you where the chain has broken down. And to fix that, more often than not, you'll just have to go to what I said is might be missing. Maybe not enough protein, maybe not eating correct foods, not having the correct lifestyle, and so on and so forth.
Yeah, that's a very good way to wrap it up. Yes, absolutely. And it's not much different than what we do with blood work. The difference is blood work is showing us the results of the genes. The genes are one step in between.
Right. Awesome. I'm mindful of your time, David, and we're probably going to do follow-up videos on this topic. But as long as it goes now, thanks for your time, and I'll catch you next video.